So I want to talk about Python optimization flags. They're pretty useless, but they're quite, I guess, interesting and fun. So we can discuss them a little bit. So usually the reason we talk about optimization flags is to avoid running assertion. So just to clarify, whenever you create a function, for example, the squared value of an input, squared value x times x, you might, be convinced the value should be positive, but maybe you've done something more complicated than that. So obviously here it's obvious, but if you've done something that you're not completely sure is correct, but the value you should get should be positive, or the list you get should have an even number of values or anything. Like if you're convinced something should happen, you should put an assertion, just so that whilst developing, if anything doesn't go exactly as you planned, it raises an error, which is pretty cool because it's basically similar to unit testing. It's not the same, but it's the same philosophy. So, for example, here you would do something like this, and if you call squared 4, it would compile and it would work. Sorry, and maybe accidentally, you make a mistake, and then when you call your function, then it doesn't work. Right. And you're happy and you debug and yeah, you're happy. But the thing is, maybe you've developed your thing, it's been in production for a month, it's been tested thoroughly, and now kind of sad because whenever you run your function, whenever you run your code, it wastes time on assertions that you now know are correct. You could want to leave the assertions just because you would want your program to crash if there's a bug, which is a valid point, and which is also probably why people, usually say those things are useless. There are other reasons we can talk about later, but if you really care about speed, and for some reason you're still doing Python, not C++ or not Rust or whatever, then there's actually a way to remove those assertions. So if you use the optimization flag, so -o, then you basically tell Python, ignore those assertions. Right? So now it's ignored, which is pretty great. Here, obviously, the assertion takes like a microsecond or something, but if the assertion was to call a complicated function, and that complicated function maybe takes 1 second, then I guess it should return something. Sorry. Then you might be happy skipping this function, right? If you don't have the flag here, the program will run for a second, and if you remove the flag, it'll only run for, I don't know, like 1 microsecond or something. So you can time it. Without the assertion, it takes like 100 milliseconds, and without the optimization flag, it runs for a second and some milliseconds. So that's the first thing we could do about assertions. Optimization flag is to remove all the assertions. The reason why I say it's kind of dangerous is because sometimes people use assertions and you don't want to remove them. And obviously if you're coding your thing on your own, then maybe you can tell, yeah, but I know I'm doing things properly, and then I control everything I do. But that's not actually true, because if you import any library, then maybe they would be doing something wrong, right? There's like an example of, this is a pull request from the CPython library. They used to write assert false to raise an error, but then there was a bug whenever people were using the assertion flag, then basically the threading module wasn't raising an error, even though it should have raised an error. So yeah, that's why everything I'm saying is kind of useless, but it's kind of fun. There's also other things you can do with optimization flags. Another thing you can do is use a sort of level 2 optimization flag, and that thing basically strips away the docstring. So docstring is like the description of your function you can add here, and this gets compiled. All right, so it could be big, and then in your .pyc, the files that get created in the PyCache folders are going to be slightly bigger, and there's an optimization flag that can remove those docstrings. So just to explain what I'm saying, because maybe not be very clear, if you do Python, just import my file, then you go into PyCache, there's a file that got created and that contains your docstring. Now, if you use the double optimization flag, you will get a slightly smaller PYC file, right? Just because it doesn't contain the docstring. And you also have opt-2 because you use the double optimization flag. If you call your file with single optimization, like level 1 optimization, you get another PYC, which will be opt1 for like level 1 optimization. And you can see the opt1 is also a little bit smaller in size than the normal file. I think that's because it doesn't contain the assertion. So that's like, smaller because you have one fewer lines. And opt2 removes docstrings. So yeah, that seems like useless unless you really care about like the space your files take on disk, which nowadays probably no one ever cared about this. It also has another problem, which is if you try to access, if you do something like squared, I think it's -doc dash. If you call this function with no optimization flags, you will get the docstring. If you call it with one optimization flag, you still get it because it's the double optimization flag that removes it. You now get none, right? So this is very consistent. And why am I talking about this? Well, the problem is some libraries might be using what is inside the docstring to run, right? And so if you strip it away, maybe then the library doesn't work. Obviously, libraries shouldn't do this, but can't control what people do. Yeah, last thing is about the type annotations. So here I'm saying like x should be an integer. This doesn't enforce anything at runtime, but usually people say that this does not change anything at runtime. And it's just for the IDE to whenever you call it with a string, the IDE will say, that's a bit weird. But people say at runtime doesn't change anything. Actually, it kind of does change something at runtime, which is that you can access the annotations at runtime. So like square.anod, this is, annotations. You can see that it says int. So you do see that. So basically, my point is, you would expect the optimization flags to do something about this, right? Because it's something that's added, and maybe we'd want to remove it. Turns out it doesn't. You can put like as many O's as you want. It won't change anything. I think there's only 2 levels of optimization. This is like technically level 1, 2, 3, 4, 5, but it just doesn't do anything. So it doesn't remove what's in the dash dash annotations dash dash. Probably because no one uses optimization flags and no one cares about optimization flags, because if you care about runtime that much or space on disk that much, you probably shouldn't be doing Python in the first place. But yeah, this little story about Python annotations, Python optimization flags. And also pretty cool thing that people usually say annotations don't change anything at runtime. They actually do change things at runtime. They even probably make your code slightly slower because they need to store all this stuff. But again, like microseconds slower, which you will never see in your life. So, very useless content, but hope it's fun.